Something changed behind the Sun in the 72 hours since 3I Atlas emerged from solar conjunction. The data coming back has left even the most skeptical astronomers searching for explanations that don't exist in any textbook. What went in as a red dusty interstellar comet came out blue, not slightly blue, not tinged with blue, bluer than the Sun itself. Before we go any further, let me ask you something that might help you share this with others who need to hear it. Where are you listening from right now? What time is it there? And have you personally observed any unusual celestial activity in your night sky recently? Drop that in the comments. Hit that like button, smash subscribe, and if you really want to help this community grow, press that new hype button and share this across your social media. Thank you for being here. Let's talk about what blue means in this context. When we observe comets, they reflect sunlight. The dust particles around them scatter that light. And basic physics tells us that dust reddens light, the same way Earth's atmosphere makes sunsets red. Larger particles scatter longer wavelengths preferentially. This is not controversial. This is undergraduate astronomy. Every comet we have ever studied, when heated by solar radiation, develops a reddish or at most yellowish hue from the dust in its coma. The Sun itself has a surface temperature of 5,800 Kelvin, giving it that familiar yellow-white appearance. For an object to appear bluer than the Sun, it needs to either be hotter than the Sun or emitting light through some other mechanism entirely. 3I Atlas, according to data from the Starry spacecraft, the SOHO Solar Observatory, and the CCOAR-1 coronagraph aboard GOES 19, became distinctly bluer than the Sun during its perihelion passage on October 29th. Not redder, as physics demands. Not the same color. Bluer. The observations came from multiple independent instruments, multiple spacecraft using different sensor technologies. This is not a calibration error. This is not a processing artifact. This is real data showing something that should not be possible. Avi Loeb published his analysis within 48 hours of the observations. He called it the 9th anomaly, adding it to a list that already stretched probability past the breaking point. His paper, which you can find linked in several astrophysics preprint servers, walks through the thermodynamics carefully. The surface of 3I Atlas, even at its closest approach to the Sun, should be roughly 10 times cooler than the solar photosphere. Cooler objects emit redder light. This is black body radiation. This is the Stefan-Boltzmann law. This is physics that has been settled since the 19th century. An object at 1/10 the temperature of the Sun cannot naturally appear bluer than the Sun through thermal emission alone. So what could cause it? Loeb proposes two categories of explanation. The natural explanation involves specific molecular emissions when certain molecules are excited by solar ultraviolet radiation. They can emit light at specific wavelengths that fall in the blue part of the spectrum. Carbon compounds, CN radicals, molecular carbon, known as C2. These can glow blue when sufficiently energized. The problem is the intensity. The blue glow from 3I Atlas was bright enough to overpower the reflected red light from its dust. That requires an enormous amount of gas emission, far more than we have ever seen from any comet. At this distance from the Sun, it would require the comet to be vaporizing mass at a rate that should have made it visibly disintegrate. And here is where it gets strange. The object did not disintegrate. The imaging from coronagraphs shows a coherent nucleus, a defined coma structure extending out to 300,000 km, and that strange blue coloration throughout. If it were experiencing catastrophic outgassing sufficient to produce this blue emission, we should see fragmentation. We should see multiple bright points as pieces break apart. We should see a debris field. We see none of that. The object maintains structural integrity while somehow producing blue light that defies straightforward explanation. The alternative explanation that Loeb carefully outlines. And I want to be clear that he frames this as speculation worth investigating rather than a conclusion. Involves artificial light sources or excess heat from an internal engine. If 3I Atlas contains any kind of power source, if it is generating heat internally rather than simply absorbing and re-radiating solar energy, that could explain the blue glow, a hot engine. Something operating at temperatures higher than its surroundings would emit light skewed toward the blue end of the spectrum. Artificial lights, if we are really going there, could be whatever color their designers chose. Now, I know what some of you are thinking. This is the same Avi Loeb who gets criticized for seeing aliens behind every asteroid. And that criticism has merit. Science requires skepticism, especially extraordinary skepticism for extraordinary claims. But let's look at what changed. In the last 72 hours before perihelion, 3I Atlas was red. Multiple observations from ground-based telescopes through July and August showed a reddish color, consistent with dust scattering, exactly what we expect. Then, in September, some observers noted it shifting toward green, which can happen as gas emissions become more prominent relative to dust. Green is common in comets. It comes from diatomic carbon and cyanogen. Nothing strange there but blue. Blue is new. Blue happened right at perihelion, right when the object was exposed to maximum solar heating, right when it was hidden from direct Earth-based observation. The timing bothers me. 3I Atlas reached perihelion at exactly 11:47 UTC on October 29th. At that moment, it was positioned behind the Sun from Earth's perspective. It had been since solar conjunction on October 21st. The only eyes that could watch it were spacecraft coronagraphs, designed to block the Sun's overwhelming light and study the corona. These instruments were not designed to do precision spectroscopy of comets. They were not optimized for this kind of observation, yet they all recorded the same thing: blue. The rapid brightening adds another layer. Comets typically brighten gradually as they approach the Sun, following a predictable power law relationship between brightness and solar distance. 3I Atlas brightened faster than any comet on record. The increase in luminosity was described by researchers at the U.S. Naval Research Laboratory as unprecedented, steeper than any previously observed cometary brightening curve. When something brightens that fast, it means energy is being released somehow, faster than the solar heating curve alone would produce. Where is that energy coming from? There is a possibility nobody wants to say out loud in academic papers, but everyone is thinking about it. What if perihelion was a test? What if something turned on? If you were designing an interstellar probe and you wanted it to remain dormant during the long, cold journey through space, when would you activate it? When would you boot up the systems, run diagnostics, prepare for the mission phase? You would do it when you reached maximum energy input. You would do it at perihelion. You would wait until the solar panels or whatever power collection system you would reach peak efficiency. And if that power-up involved heat, involved energetic processes, involved systems that emit light, you might see exactly what we saw: a rapid brightening, a color change, blue light where red should be. I'm not saying that is what happened. I am saying the data we have is consistent with that interpretation, and we do not have enough information to rule it out. Science is not about believing comfortable explanations. Science is about following evidence, even when it leads somewhere uncomfortable. The evidence right now says 3I Atlas did something at perihelion that natural comets do not do. The comparison to previous interstellar visitors is instructive. Oumuamua never showed cometary activity. never developed a coma, never had a color change because it never had volatiles to outgas. Borisov looked like a normal comet throughout its passage. Reddish color, predictable brightening, standard tail development. Everything by the book. 3I Atlas is neither. It has cometary features, yes. It has a coma. It had a tail. It shows outgassing. But the details are wrong. The chemistry is wrong. The behavior is wrong. And now the color is wrong. There is another element to consider. The blue color was not uniform. Images from the Punch satellite constellation, processed by citizen scientists within hours of release, showed structure in the blue emission. Not just a uniform glow, but patterns, variations in intensity across the coma. Structured emissions suggest structured sources. Random outgassing from a chaotic cometary surface should produce a relatively smooth brightness distribution. Maybe some jets, but not geometric patterns. The processing is preliminary. The images are noisy, but several independent analysts reported seeing what looked like discrete bright points within the coma, points that were bluer than their surroundings. If those hold up under more rigorous analysis, we have another problem, because that is not how comets work. Blue also means energetic. Photons in the blue part of the spectrum carry more energy than red photons. To shift emission from red to blue, you need to input energy into the system. Solar heating provides energy. Absolutely. But that energy should produce a thermal spectrum, a black body curve that peaks in the infrared for an object this cold and extends into the visible as a reddish glow. Blue emission requires non-thermal processes. It requires energy being channeled into specific excitation mechanisms that produce high-energy photons preferentially. Chemistry can do that, so can other things. The frustrating part is that we miss the peak. Perihelion was October 29th. Ground-based telescopes lost sight of 3I Atlas on October 9th or 10th, depending on location. As it moved into the solar glare, it will not be visible again from Earth until November 11th, 2 weeks after perihelion. 2 weeks after whatever happened by the time we can point our big telescopes at it. The moment will have passed. The object will be moving away from the sun, cooling down. Whatever processes caused the blue glow may have shut off. We are looking at echoes, at after effects, at data collected by instruments that were not designed for this observation, the spacecraft that could have told us everything, the Mars Reconnaissance Orbiter with its high-rise camera, that observed 3I Atlas on October 2nd and 3rd from just 30 million kilometers away, with a resolution 3 times better than Hubble. That data is locked behind a government shutdown and bureaucratic walls. Avi Loeb has been screaming about this for a week. Congresswoman Anna Paulina Luna wrote a formal letter to NASA demanding release. As of this morning, nothing. We have pixelated coronagraph images showing blue when we should see red, and the high-resolution data that might actually explain it is sitting in a server somewhere, classified or embargoed, or just lost in the shuffle of a government that cannot keep its lights on. So we are left with blue, unexplained, unprecedented, impossible blue, a color that rewrites what we thought we knew about interstellar objects, or confirms what some of us feared we might eventually find. The object goes back into view in 8 days. Telescopes around the world are already reserving time. The question is whether the blue will still be there, whether it was a momentary phenomenon tied to peak solar heating, or whether it represented something that turned on, looked around, and is now deciding what to do next. The next chapter in this story is being written right now, 30 million kilometers above Mars' orbit, moving at 68 kilometers per second, glowing a color it should not be. And we are down here waiting for November 11th. hoping the blue gives us answers. Terrified it might give us questions we are not ready to ask. Now let's talk about movement, because the color is not the only thing that changed. NASA confirmed it 3 days ago. The document appeared quietly in a technical report. No press release, no fanfare, just dry orbital mechanics showing something that should not be there. 3I Atlas is accelerating without gravitational cause. The object is changing velocity, altering its trajectory in ways that cannot be explained by the sun's gravity, planetary perturbations, or any other purely gravitational effect. Let me be precise about what this means. Every object in space moves according to gravity. Planets orbit stars. Moons orbit planets. Comets fall toward the sun and swing back out, all following paths dictated by gravitational fields. You can predict these orbits with extraordinary accuracy. Give me an object's position and velocity at any moment. Tell me the masses and locations of nearby bodies, and I can calculate where that object will be years from now, accurate to within kilometers. This is Newtonian mechanics. This is JPL's bread and butter. This is how we navigate spacecraft across billions of kilometers and arrive exactly on target. 3I Atlas is not following that path. The deviation is small, but it is real, measurable, and growing. NASA's orbital analysis detected 2 distinct components of non-gravitational acceleration. The first is radial, pointing away from the sun with a magnitude of 135 kilometers per day squared. The second is transverse, perpendicular to the sun's direction, measuring 60 kilometers per day squared. These are not rounding errors. These are systematic, persistent accelerations that compound over time. Now, non-gravitational acceleration is not inherently mysterious. Comets do this all the time when ice vaporizes from the surface of a comet nucleus. It jets off into space, and Newton's third law kicks in action and reaction. The escaping gas pushes the comet in the opposite direction. This rocket effect, called outgassing, is well understood, thoroughly modeled, and entirely natural. We see it in every active comet. The question is not whether comets can accelerate without gravity. The question is whether the acceleration we are seeing matches what outgassing alone should produce. Let's do some physics. The radial acceleration, pointing away from the sun, makes sense for outgassing. As the sun heats the sunward side of the nucleus, ice sublimates. Gas escapes preferentially in the sunward direction. The rocket effect pushes the comet away from the sun. This is textbook stuff, but the magnitude matters. 135 kilometers per day squared translates to a specific thrust, and that thrust requires a specific mass loss rate. You can calculate how much material the comet needs to be ejecting to produce this acceleration. The numbers are large, very large. Avi Loeb ran these calculations in his latest paper for 3I Atlas. To generate the observed radial acceleration through outgassing alone, it would need to lose approximately 15% of its total mass over the coming months. 15%. We're talking about billions of tons of material. An object, 33 billion tons in mass, shedding 5 billion tons. That is not gentle sublimation. That is catastrophic. That is the kind of mass loss you see when a comet breaks apart, when structural integrity fails, when the whole thing starts coming unglued. And yet, 3I Atlas is not breaking apart. The imaging shows a coherent object. The coma structure remains organized. There is no debris field, no fragmentation, no sign of disintegration. The transverse acceleration is even stranger, 60 kilometers per day squared, perpendicular to the sunline. Outgassing can produce transverse acceleration, if the nucleus is rotating and the jets are not aligned with the sun direction. Imagine a spinning comet with a jet on one side. As it rotates, the jet sweeps around, producing a sideways push. This happens. But the magnitude of transverse acceleration we are seeing requires either extremely asymmetric outgassing or a very specific rotational configuration, and we have not detected the kind of rotational variations in brightness that would indicate such dramatic asymmetry. The light curve is too smooth. The variations are too subtle, so we have an object that is accelerating radially more than most comets, accelerating transversely more than it should, and not showing the expected signs of the outgassing that would explain it. This is the engine hypothesis in a nutshell. What if the acceleration is not from passive outgassing? What if something is actively thrusting? Let's think about how an interstellar spacecraft would maneuver. You've been traveling for millions of years through the void. You enter a solar system. You need to adjust your trajectory to achieve specific objectives, maybe to pass close to planets for observation, maybe to decelerate into orbit, maybe to position yourself for the next leg of the journey. When do you fire your engines? You fire them at perihelion. This is orbital mechanics 101. When you're moving fast, deep in a gravity well, thrust is most efficient. A velocity change at perihelion translates to a much larger change in your orbital energy than the same thrust applied farther out. Every spacecraft engineer knows this. Every mission that has ever done a gravity assist has exploited this. 3I Atlas reached perihelion on October 29th. The non-gravitational acceleration was detected in the orbital fitting that includes data from before and after perihelion. The acceleration parameters changed. They were different after perihelion than before. Not dramatically, not like someone slammed the throttle open, but measurably. The kind of change you might see if a propulsion system activated, made a burn, then throttled back down. I'm not saying this is what happened. I'm saying the data is consistent with it, and the alternative explanation requires us to believe that a comet is behaving in ways comets do not behave, while somehow avoiding the consequences that should follow from that behavior. Outgassing that produces this much thrust should produce visible mass loss. We're not seeing it. Outgassing this asymmetric should produce rotational signatures. We are not seeing them. What we are seeing is an object that accelerates like it has an engine. The timing makes it worse. The trajectory of 3I Atlas, as we have discussed in previous videos, brings it within tens of millions of kilometers of Mars, Venus, and Jupiter. It passes through the inner solar system on a path that is aligned to within 5 degrees of the planetary plane. That alignment has a probability of 0.2% if the trajectory is random. Now, at the non-gravitational acceleration, that acceleration is fine-tuning the trajectory. It is making small corrections, and those corrections are steering 3I Atlas along a path that optimizes planetary encounters. Coincidence stacked on coincidence, stacked on coincidence. Let's talk about what an engine would look like. We are not talking about chemical rockets. Chemical propulsion is too inefficient for interstellar travel. You would need more fuel than payload by factors of millions. Not practical. The candidates are ion drives, nuclear thermal propulsion, fusion, antimatter, or something we have not invented yet. Ion drives produce very small thrust over very long periods. The acceleration we are seeing from 3I Atlas is too large for ion propulsion. Given the implied mass, nuclear thermal could work. You heat reaction mass. You eject it out through a nozzle. You get thrust. The specific impulse is much better than chemical. The thrust is modest but real, and the fuel efficiency is within the realm of possibility for interstellar missions. Fusion would be better. Antimatter would be better still, or maybe something that does not involve throwing mass out the back at all. Maybe some propulsion principle we have not discovered, some way of pushing against space itself. The problem with all of these is detection. An engine produces exhaust, hot gas, charge particles, electromagnetic signatures, something we should be able to see. Telescopes should pick up emission lines from whatever the working fluid is. Spectrographs should show velocity signatures from material streaming away. And we do see outgassing. We do see gas emission. We do see spectral lines. But what we see is consistent with cometary activity water. Carbon dioxide, carbon monoxide, cyanide, nickel compounds. Is that the engine exhaust cleverly disguised as comet outgassing? Or is it actual comet outgassing and the engine is something cold? Something that does not produce a visible plume? Something that pushes in ways we're not looking for? The acceleration continues as 3I Atlas moves away from the Sun, as it cools, as solar heating decreases. We should see the non-gravitational acceleration drop. Outgassing is driven by solar heating. Less heat, less gas, less thrust. If the acceleration does not decrease, if it remains strong or even increases as the comet recedes, that would be very difficult to explain naturally. We will know in a few weeks. Observations starting November 11th will give us new orbital data. The Minor Planet Center will update the ephemeris. The acceleration parameters will be refined, and we will see if 3I Atlas is still thrusting, still tweaking its trajectory, still acting like something that knows where it is going. In the meantime, we have NASA's confirmation sitting in a technical document and Avi Loeb writing papers about engines, and the rest of the astronomy community quietly running their own calculations, checking the numbers, trying to find the error that makes it all go away. So far, nobody has found it. The acceleration is real. The question is what is causing it, and whether we are brave enough to consider all the possibilities. And that brings us to the chemistry, because what this object is made of is perhaps the strangest part of the entire story. 4 grams per second. That is how much nickel 3I Atlas is ejecting into space. Not trace amounts, not parts per billion contamination. 4 grams every single second streaming away from the nucleus in a plume that should not exist. And the iron that should be there. The iron that is always there when you find nickel in cosmic objects, is missing. Not reduced, not depleted, missing. Dr. Gregory Rogers put it bluntly. Rogers is not some fringe theorist. He served as a U.S. Air Force flight surgeon. As chief of aerospace medicine at Cape Canaveral, he worked with spacecraft, with materials, with the actual hardware that goes into orbit. When he says the composition is impossible, he's speaking from direct experience with what natural and artificial objects look like chemically. His statement, made public last week, cuts through the academic hedging. Naturally formed cosmic objects contain iron and nickel together. Always, the ratio varies, but both are present. 3I Atlas has nickel without iron. That does not happen in nature. Let's talk about where nickel and iron come from. They are both produced in stellar nuclear synthesis, the fusion reactions inside massive stars. As stars burn through their fuel, they build heavier elements, carbon, oxygen, silicon, and eventually iron. Iron is the end of the line for fusion that releases energy. Anything heavier requires energy input and happens only in supernovae. Nickel is produced alongside iron in these processes. When the star explodes, both elements are ejected into space. They mix with the interstellar medium. They condense into dust grains. They accrete into planets, asteroids, comets, and they're always together. The cosmic abundance ratio of iron to nickel is roughly 18 to 1. You can find objects that are iron-rich. objects that are nickel-rich. But you cannot find nickel without at least some iron. It is like finding hydrogen without finding helium. The physics does not allow it. 3I Atlas is somehow achieving it. The spectroscopic observations are unambiguous. The Very Large Telescope in Chile detected strong nickel emission lines in the coma. Multiple observatories confirmed it. The James Webb Space Telescope analyzed the chemistry in detail. Nickel is abundant. Iron is not detected. The upper limits on iron concentration are orders of magnitude below what should accompany that much nickel. This is not a measurement error. This is not a calibration problem. Multiple instruments, multiple techniques, all seeing the same thing. The compound being emitted is almost certainly nickel tetracarbonyl. The spectral signatures match. Nickel tetracarbonyl is a molecule. Nickel bonded to 4 carbon monoxide groups. It is volatile, evaporates easily, breaks down under ultraviolet light into nickel atoms and carbon monoxide, all of which we see in the spectrum. The question is where the nickel tetracarbonyl came from. On Earth, we manufacture it. The Mond process, developed in the 1890s, uses nickel tetracarbonyl to refine nickel to high purity. You take in pure nickel, you expose it to carbon monoxide gas. Nickel tetracarbonyl forms. You heat it. Pure nickel deposits out. It is industrial chemistry. It happens in refineries, not in space. Can it form naturally? Technically, yes. You need nickel. You need carbon monoxide. You need the right temperature and pressure conditions. Carbon monoxide is common in comets. Nickel is present in cosmic dust. If you had a comet with an unusual concentration of metallic nickel grains embedded in the ice, and those grains were exposed to carbon monoxide gas, as the ice sublimated, you might get some nickel tetracarbonyl formation. Might. The problem is the concentration. We are not seeing trace amounts. We are seeing emission rates that imply kilograms of nickel being released every day. That requires a lot of metallic nickel in the nucleus, far more than cosmic abundances would suggest, and it still does not explain the missing iron. If the nickel came from normal stellar nucleosynthesis, the iron should be there too. Iron also forms carbonyls. Iron pentacarbonyl is a known compound. If carbon monoxide is reacting with nickel, it should react with iron. We should see both. We see only one. The ratio to cyanide makes it worse. Cyanide CN radicals are common in comets. They come from organic compounds breaking down under solar radiation. The amount of cyanide in a comet's coma tells you about the organic chemistry in the nucleus. 3I Atlas has a normal amount of cyanide, maybe even slightly low, but the nickel to cyanide ratio is orders of magnitude higher than any known comet. Orders of magnitude. Avi Loeb calculated the probability of this ratio occurring naturally in a comet with the composition we see, less than 1%. Add it to the list. Dr. Rogers made the point about spacecraft materials. When we build satellites, when we design space probes, we use nickel alloys, not because nickel alone is ideal, but because nickel alloys have properties we need: corrosion resistance, high temperature strength, dimensional stability, and in some specific applications, we use nickel without much iron, nickel 200 for example, pure nickel used in electronics, in specialized components where magnetic properties or chemical resistance matter. If you were designing a spacecraft to survive millions of years in interstellar space, to withstand cosmic radiation, to maintain structural integrity through temperature extremes, you might choose materials similar to what we choose. High nickel content, low iron to avoid magnetic interference or oxidation issues. And if that spacecraft were damaged, if it were ablating material, If it were leaking volatiles that had been stored in nickel alloy tanks, you might see exactly what we are seeing: nickel emission without iron. This is not proof. This is a scenario that fits the data. But here is what troubles me. We have multiple explanations for individual anomalies. The blue color could be ionized carbon monoxide. The acceleration could be asymmetric outgassing. The nickel could be unusual but natural chemistry. Each one taken alone is unlikely but possible, but they are not independent. The blue color, the acceleration, and the nickel emission are all happening in the same object at the same time, and the chemical processes that might explain the nickel are the same processes that might explain the blue color, and both are tied to the energy budget that drives the acceleration. Everything connects. Either we have a comet that is simultaneously unusual in 8 or 9 different, independent ways, each with a low probability, or we have something where the anomalies are connected, where they all follow from a single underlying cause that we are not identifying because we are assuming the object is natural. The water percentage adds to this. Normal comets are mostly water ice. 50 to 80% water by mass is typical. 3I Atlas is 4% water. 4. The rest is carbon dioxide, carbon monoxide, organics, and apparently a lot of nickel-bearing compounds. A comet that dry is rare, not impossible. We have seen carbon monoxide-dominated comets before, but rare and convenient if you think about it. Water is heavy. Water is bulky. If you were designing a propulsion system that vaporizes, stored volatiles for thrust, you might choose carbon monoxide or carbon dioxide over water. Better specific impulse, less mass to carry. The low water fraction makes 3I Atlas a worse comet by normal standards, but a better spacecraft by engineering standards. The timing of the nickel emission is also interesting. The detection came from observations in July and August, when 3I Atlas was still far from the Sun. Comets typically do not emit much metal that far out. Metal emission requires significant heating to vaporize refractory grains, but nickel tetracarbonyl is volatile. It does not require high temperatures. It can sublime at much lower temperatures than water ice. If the nucleus contains pockets of nickel tetracarbonyl, perhaps in subsurface voids, perhaps in storage tanks if we're going with the artificial scenario, those pockets could vent early, producing the observed emission before the comet is fully active. Then there is the anti-tail, the feature that shows up in the Hubble image from July, a jet of material pointing toward the Sun instead of away from it. We talked about this in earlier videos. Anti-tails are known. They are usually optical illusions from viewing geometry, but the 3I Atlas anti-tail is real. Multiple viewing angles confirm it. It is actual material moving sunward. Jets can do that if they are on the night side of the nucleus and the rotation carries them into view. But the geometry has to be very specific, or the material is being actively propelled sunward. Exhaust from a nozzle pointing forward. Reaction control thrusters making attitude adjustments. And if you are ejecting nickel-bearing volatiles as part of that process, you get the chemistry we see. I want to be careful here. I am not claiming 3I Atlas is artificial. I am claiming the chemistry does not make sense for a natural object, and the alternative explanations require assumptions that are individually unlikely and collectively improbable. The scientific method is supposed to handle this. When your hypothesis does not fit the data, you revise the hypothesis. When multiple unlikely things have to be true simultaneously, you look for alternative frameworks that explain them more parsimoniously. But the alternative framework here is so far outside the mainstream, so disruptive to our understanding of our place in the universe, that the threshold for acceptance is enormous, which is appropriate. Extraordinary claims require extraordinary evidence, but at some point, the accumulation of ordinary evidence pointing in an extraordinary direction has to be taken seriously. NASA's position is clear. Acting Administrator Shaw Duffy responded to a question from Kim Kardashian, which is somehow where we are in 2025, by saying no aliens, no threat to Earth. ESA says the same thing. The consensus view is a natural comet with unusual properties, and that view is held by smart people, serious scientists, experts in the field. I respect that. But consensus is not the same as correct. Consensus said Oumuamua was a comet until the data forced a reclassification to asteroid. Consensus said interstellar objects would be rare until we found 3 in 8 years. Consensus is what we believe until we have reason to believe something else. The nickel is that reason, or part of it. 4 grams per second of an industrial compound emitted from an object that has no business containing it, lacking the iron that should accompany it, appearing in ratios that defy natural chemistry. Something made that nickel. Something separated it from iron. Something put it into 3I Atlas. The question is whether that something was a supernova and billions of years of unlikely chemistry, or whether it was intelligence, engineering, intention. And this leads us to the most frustrating part of the story. The data we don't have. The most important images of 3I Atlas were taken on October 2nd and 3rd. They were captured by the high-rise camera aboard NASA's Mars Reconnaissance Orbiter, as the interstellar visitor passed within 30 million kilometers of Mars. The resolution is 30 cm per pixel, 3 times better than the best Hubble images. These pictures could show surface features, compositional variations, structural details that might settle the question of what this object actually is, and they have not been released. Avi Loeb went on the Joe Rogan Experience on October 28th. The episode released October 29th. 2.5 hours of conversation covering 3I Atlas, Oumuamua, the search for extraterrestrial intelligence, and the institutional resistance Loeb faces in academia. But the part that matters for this story, the part that has been clipped and shared across every platform, is when Loeb talks about the high-rise images. He is visibly frustrated. He explains that NASA had 4 weeks to release the data. 4 weeks during which the scientific community has been starved for high-quality observations of the most anomalous object we have ever tracked. And the images are being held. Joe Rogan suggested Loeb contact the interim NASA administrator directly, Shaw Duffy. The next day, Loeb followed through. He coordinated with Congresswoman Anna Paulina Luna, who represents Florida's 13th District, which includes Cape Canaveral. Luna has been supportive of frontier science, has pushed for transparency in space exploration, and apparently takes this seriously. She wrote a formal letter to Shaw Duffy on October 30th. The letter is public. You can find it online. She requests that NASA release the high-rise data immediately, cites the scientific importance, and points out that the U.S. government shutdown is not a valid reason for withholding information that has already been collected. As of this morning, November 3rd, there has been no response. No data release, no acknowledgement. The shutdown started October 1st. The timing is suspicious. 3I Atlas made its closest approach to Mars on October 3rd. The Mars Reconnaissance Orbiter was perfectly positioned. High-rise was activated. The observations were made, and then the government shut down. NASA went into minimal operations mode. Data sharing stopped. Not just for 3I Atlas. For everything. Multiple missions are affected. Scientists who rely on NASA data for ongoing research are locked out. International collaborators are getting automated bounce-backs from NASA email addresses. This is not a targeted suppression of 3I Atlas information. This is bureaucratic dysfunction affecting everything equally. But the timing. October 1st, the same day as critical observations. The same day ESA's Mars Express and ExoMars Trace Gas Orbiter were also imaging 3I Atlas. ESA released their data. Granted, their images are not great. The cameras are designed for Mars surface imaging, and 3I Atlas is 10,000 to 100,000 times fainter than their normal targets. The comet shows up as a slightly fuzzy white dot, not useful for detailed analysis. But they released it. NASA has not, Lowe framed it perfectly on Rogan's show. It is much more likely to be terrestrial stupidity than extraterrestrial intelligence. He is not claiming a conspiracy. He is claiming incompetence, misplaced priorities, institutional inertia. NASA is shut down over budget politics. The scientists who would process and release the high-rise data are furloughed or working without pay. The people who make decisions about data release are dealing with bigger fires, keeping critical missions alive, managing the chaos. 3I Atlas is not a priority, even if it is the third interstellar object ever observed, even if it is behaving anomalously, even if the scientific community is desperate for the data. NASA has other problems. But here is where it gets complicated. The high-rise data is not raw. It has been processed. The MRO team has standard pipelines for handling camera data. The images were taken on October 2nd and 3rd. We are now a month later. Processing should be done. The images should be in the archive ready for public release. NASA's policy for Mars missions is open data. Everything goes into the planetary data system within a few months, available to anyone. This is standard practice required by NASA's charter. The data belongs to the public. Researchers around the world use it. Students write dissertations on it. It is not classified. It is not sensitive. It is Mars and 3I Atlas, while anomalous, is not a security issue. It is a comet, or whatever it is, on a trajectory that keeps it far from Earth. No threat, no danger. Just interesting. So, why the delay? One possibility is that the images show nothing unusual. 3I Atlas looks like a comet. The surface is icy. The morphology is normal. The color is reddish or grayish. Exactly what you expect if that is the case. Why not release them? Releasing the data would shut down the speculation, would give Lowe and everyone else exactly what they're asking for, would demonstrate transparency. Another possibility is that the images show something unusual, and NASA is trying to figure out how to explain it before going public, which would be reasonable. If the unusual thing is scientifically interesting but not paradigm-shifting, if high-rise captured details of outgassing jets or compositional heterogeneity, or surface structures that challenge our models of cometary activity, you might want to get your ducks in a row before the media circus starts. But a month is a long time. How complicated can the explanation be? The third possibility is that someone somewhere in the chain of command decided this data is too hot to release without approval from higher up. And higher up is not available because of the shutdown. This is bureaucracy, not conspiracy. Someone covers their ass, defers the decision, waits for guidance, and the data sits. Lowe thinks this is what happened. He said as much. The system is risk-averse. Nobody wants to be the person who released controversial data without clearance, so nobody releases anything. Congresswoman Luna's letter tries to cut through that. She's asking Duffy, as acting administrator, to personally authorize the release. She's giving him political cover. She's saying this is important. The public wants it. Science needs it. Do the right thing. Whether Duffy will respond is unclear. Interim administrators are in survival mode. They're keeping the lights on, managing crises, not making bold moves, releasing data about an anomalous interstellar object. When a Harvard professor is on the largest podcast in the world saying it might be alien technology, is not a safe play. It is much easier to do nothing. Here is what makes me angry. We have one shot at this. 3I Atlas is a once-in-a-lifetime object. It is the third interstellar visitor we've ever detected. The first that we discovered early enough to watch its full evolution as it approached the Sun. We have spacecraft at Mars. We have spacecraft near the Sun. We have the James Webb Space Telescope, the Hubble Space Telescope, the best astronomical instruments humanity has ever built, all pointed at this thing. And the data is being held up by budget politics, by a government that cannot agree on spending priorities, by a system that treats scientific discovery as optional. Loeb has been screaming about this because someone needs to. The rest of the astronomy community is more polite. They write careful papers. They phrase things diplomatically. They do not want to alienate NASA because NASA funds their research. Loeb does not care. He has tenure at Harvard. He has independent funding through the Galileo Project. He can afford to burn bridges, and he is using that position to demand what should not need demanding: release the data. Show us what you saw. The Joe Rogan appearance amplified this message to millions of people. Rogan's audience is not the academic astronomy community. It is the general public, people who are curious about space, about aliens, about mysteries. Loeb went on that show knowing he would reach those people, knowing the message would spread, knowing it would put pressure on NASA in ways that academic papers cannot. And it worked. The story is now mainstream, but we still do not have the images. And every day that passes is a day when the context matters less. The moment is passing. The E-window, where those images could tell us something definitive, is closing. There is a broader point here about how we handle anomalous data. When something does not fit our expectations, the instinct is to be cautious, to double-check, to wait for confirmation. That is good science. But it can also be paralysis if every unusual result has to be vetted and approved and sanitized before release. We lose the rapid iteration that makes science work. We lose transparency. The high-rise images might show a boring comet. They might show something interesting but explicable. They might show something that rewrites what we think we know. We will not know until NASA releases them, and NASA will not release them until the shutdown ends, or until someone in authority decides this is important enough to override standard procedures. And as if the story needed another layer of mystery, there's a ghost from 1977 to consider. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected something it should not have. A strong, narrow-band radio signal at 1420 megahertz, the hydrogen line, the frequency that every radio astronomer watches. Because hydrogen is the most abundant element in the universe, and any civilization trying to signal across interstellar space might use it. The signal lasted 72 seconds, exactly as long as Big Ear's observation window for any given point in the sky. It was so strong, so unexpected that astronomer Jerry Eyman wrote "Wow" in red pen on the computer printout. The name stuck, the WOW signal, and despite decades of searching, despite multiple attempts to detect it again, it never repeated. One burst, 72 seconds, silence. 3I Atlas came from the same direction within 9 degrees. Avi Loeb calculated this 2 months ago, published the analysis in September. The WOW signal originated from right ascension 19 hours, 25 minutes. Declination minus 27 degrees on August 12th, 1977, 3 days before the signal was detected. 3I. Atlas was at right ascension 19 hours, 40 minutes, declination minus 19 degrees. The total angular separation is about 9 degrees. The probability that two random directions in the sky are aligned to that level is 0.6%. Let's think about what this means. The WOW signal was detected in 1977. At that time, 3I Atlas was approximately 600 astronomical units from Earth, 600 times the Earth-Sun distance. Light travel time, 3 days. The signal traveled from wherever it originated, reached Earth on August 15th, and if it came from 3I Atlas, it left the object on August 12th. The timing works. The geometry works. The frequency works. Now, the immediate objection is that we do not know the WOW signal came from that exact point. We know it came from somewhere in that region of the sky, but Big Ear's beam was wide, several degrees across. The exact point of origin could be anywhere within that beam, and yes, that uncertainty exists, but 9 degrees is well within the beam width. 3I Atlas would have been in the field of view. The frequency is interesting. 1,420 megahertz is not arbitrary. It is the hyperfine transition of neutral hydrogen, when the electron in the hydrogen atom flips its spin relative to the proton. It emits or absorbs a photon at this exact frequency. This is the famous 21-centimeter line, the line that radio astronomers use to map hydrogen in the galaxy. The line that SETI searches focus on, because any technological civilization would know about it. If you want to send a signal that will be recognized as artificial, you use a frequency that means something. 1,420 megahertz means something. It says we know physics, we know astronomy. This is deliberate. The WOW signal was strong, very strong. The intensity was 30 times above the background noise level. For comparison, typical cosmic radio sources that Big Ear detected were maybe 2 or 3 times background. 30 is huge. It implies either a very powerful transmitter or a transmitter that is relatively close. Loeb calculated what power would be needed if the signal came from 3I Atlas at 600 AU, about 1 gigawatt. That is the output of a nuclear power plant. Not unreasonable for a technological civilization. But here's the problem. The signal did not repeat. Astronomers have searched that region of the sky hundreds of times since 1977. Different telescopes, different frequencies, different observing strategies. Nothing. The biggest telescope itself observed the same spot again multiple times. Silence. Whatever caused the WOW signal, it was a one-time event, or at least a very rare event, and we have not caught it again in nearly 50 years. If 3I Atlas transmitted the WOW signal, why send a single burst in 1977 and then go quiet? One possibility is that it was a test, an interstellar probe activating its transmitter, checking that it works, announcing its presence, then shutting down to conserve power for the long journey. Another possibility is that it was not aimed at us. Maybe 3I Atlas was communicating with something else. Another probe, a relay station, a home base. We happened to be in the beam path. We were eavesdropping. Or maybe it was aimed at us, and the lack of repetition means we failed the test. We detected it. We wrote WOW on a printout. And then we did nothing. We did not respond. We did not follow up with a coordinated search. We did not take it seriously. Big Ear was demolished in the 1990s to make room for a golf course. If someone wanted to know if humanity was paying attention, the WOW signal would have told them we are not. We noticed, barely, and then we moved on. The 0.6% probability is not nothing. If you did this analysis for every object in the solar system, you would find coincidences. But 3I Atlas is not a random object. It is already anomalous in 8 other ways. The WOW signal connection is the 9th coincidence, stacked on top of the others. At what point do you stop calling them coincidences? Loeb made a broader point in his analysis. We send signals into space, the Arecibo message in 1974, the Voyager golden records. We assume that if someone is out there, they might be listening. But we also assume that if someone sends a signal to us, we will recognize it. We will take it seriously. The WOW signal was exactly the kind of signal SETI is looking for. Strong, narrowband, at a significant frequency from outside the solar system, and we did not follow up. If that signal was a message, we ignored it. Now, 50 years later, the object that might have sent it is in our solar system. It passed Mars in October. It is heading toward its closest approach to Earth in December. And we're arguing about whether it is a comet. Maybe the WOW signal was the announcement. Maybe 3I Atlas is the follow-up. Maybe we are being given a second chance and we are blowing it again. Radio astronomers are now monitoring 3I Atlas after Loeb published the WOW signal connection. Several groups quietly started observations. They are looking for transmissions at 14 to 8 megahertz, at other frequencies, checking for pulsed signals, for anything that might indicate active communication. So far, nothing has been reported publicly. There is also the question of whether we should respond. SETI protocols say yes. If we confirm it is artificial, we should respond carefully with messages crafted to convey peaceful intent. But others say no. We do not know the intent. We do not know what 3I Atlas is looking for. The dark forest hypothesis. The idea that the universe is full of civilizations hiding from each other would argue for silence. Do not provoke. Do not engage. Stay hidden. I do not know which is right. I do know that we're not having this conversation at the level it deserves. The WOW signal connection should be front-page news. Instead, it is a footnote, a statistical coincidence that most astronomers dismiss without serious consideration. The signal came from the right direction. The object came from the right direction. 50 years apart, 0.6% chance. And now the object is here doing things that comets do not do. And we are pretending it is not connected. Maybe it is not. But if we are wrong, if the WOW signal was 3I Atlas saying hello and we ignored it, and now it is here and we are still ignoring it, history will not be kind. So let's put all the pieces on the table, 9 anomalies. 9 separate observations that each deviate from what we expect for a natural interstellar comet. Avi Loeb maintains a list, updates it as new data comes in, calculates the probability for each one. When you multiply probabilities together, when you ask what the chances that all 9 occurred simultaneously in the same object by random chance, you get a number so small it stops meaning anything. 1 in 10 quadrillion, 1 in 10 to the 16th power. For context, there are about 100 billion stars in the Milky Way galaxy. 1 in 10 quadrillion is 100,000 times less likely than picking one specific star at random from the entire galaxy. Let's go through them one by one, not to rehash what we have already covered in detail, but to see the pattern, to understand why this is not about any single anomaly, but about the collection, the totality, the cumulative weight of evidence that keeps pushing in the same direction. Anomaly 1. The trajectory is aligned to within 5 degrees of the ecliptic plane, the plane where the planets orbit the Sun. Most objects in interstellar space move in random directions. The chance that an interstellar object's trajectory just happens to align with our planetary plane is about 0.2%. Not impossible, but rare. Now, If you are a probe designed to survey a solar system, you would absolutely align your trajectory with the ecliptic. That is where the interesting stuff is. Random comets do not care about our planets. Probes do. Anomaly 2. The anti-tail from July through August. 3I Atlas displayed a jet of material pointing toward the sun. We have discussed this. Anti-tails can be optical illusions, but this one is not. Multiple viewing angles, multiple observations, all confirm it. Real material moving sunward. Comets do not do this naturally, because solar radiation pressure pushes material away from the sun. The only natural way to produce a real sunward jet is very specific: rotation and outgassing geometry. Or it is exhausted from a thruster. Anomaly 3. The size. The nucleus is at least 5 kilometers in diameter, possibly larger, making the total mass at least 33 billion tons. That is 1,000,000 times more massive than Oumuamua, 1,000 times more massive than Borisov. Interstellar objects should follow a size distribution. Smaller objects should be far more common than larger ones. We have detected 3 interstellar objects. The first is tiny, the second is medium, the third is huge. The probability of detecting the huge 1/3, given expected population statistics, is very low. If 3I Atlas is artificial, you build it as big as you need a mothership, a generation ship. Mobile base. Anomaly 4. The timing and geometry of its passage. 3I Atlas reaches perihelion on October 29th. At that moment, it is unobservable from Earth, hidden behind the sun, but it passes within tens of millions of kilometers of Mars, Venus, and Jupiter. The trajectory is fine-tuned to give close encounters with multiple planets while remaining invisible to Earth-based telescopes during the most critical phase. The probability of this geometry occurring by chance, according to Loeb's calculation, is 0.05%. If you wanted to survey the inner solar system without revealing yourself to the dominant civilization, this trajectory is exactly what you would design. Anomaly 5. The nickel-to-iron ratio. We have covered this extensively. Nickel emission without corresponding iron. 4 grams per second of nickel. Orders of magnitude more than the nickel-to-cyanide ratio in any known comet. Probability of this ratio occurring naturally. Less than 1%. Industrial chemistry. Artificial materials, or wildly unusual natural chemistry that we have never seen before. Anomaly 6. The water fraction. 4% water by mass. Normal comets are 50 to 80% water. Carbon dioxide and carbon monoxide dominate 3I Atlas. This makes it a bad comet by natural standards, but an efficient spacecraft by engineering standards. Less mass to carry, better propulsion characteristics. Probability less than 1%. Anomaly 7, the extreme negative polarization. When light reflects off a surface, it becomes polarized. The degree and direction of polarization tells you about the surface properties. 3I Atlas shows extreme negative polarization, more negative than any known comet, including Borisov. This suggests surface or particle properties that are unprecedented. Probability less than 1%. Metallic surfaces, engineered materials, or just weird ice and dust configurations. Anomaly 8. The WOW signal alignment. 9 degrees lost. 6% probability. 50 years ago, a signal. Now, an object from the same direction. Could be coincidence. Could be a message and a messenger. Anomaly 9. The blue color and rapid brightening at perihelion. Added to the list less than a week ago. Bluer than the sun. brightening faster than any known comet, inconsistent with thermal emission from a cold object, requires intense gas emission or an alternative energy source. The ninth anomaly, the newest anomaly, the one that came from watching what happened behind the sun. 9 anomalies. Each one has a probability attached. Each one is unlikely but possible. Multiply them together and you get 1 in 10 quadrillion. Loeb argues that this number is so small, so far beyond reasonable chance that we must seriously consider the alternative. The hypothesis is that 3I Atlas is not natural, that it is a technological artifact, that the anomalies are not independent coincidences, but connected features of a designed object. The counter-argument is that the probabilities are not independent. If 3I Atlas formed in an unusual environment with weird chemistry, that chemistry would affect multiple properties. The nickel, the water fraction, the polarization could all stem from a single unusual formation scenario. You do not multiply the probabilities because they are not independent events. This is a fair argument, but what formation environment produces nickel without iron? Aligns trajectories with ecliptic planes and sends wow signals. Occam's razor is supposed to favor simpler explanations. But simplicity is not just about counting hypotheses. It is about counting assumptions. The natural comet hypothesis assumes unusual chemistry, unusual trajectory, unusual timing, unusual composition, unusual emissions, unusual everything. The artificial object hypothesis assumes one thing, intelligence. And intelligence, as far as we know, exists. We are proof. Loeb developed a scale for this. The Loeb scale, running from 0 to 10. 0 means definitely natural. 10 means definitely artificial. He ranks 3I Atlas at a 4, midpoint uncertain. More anomalies than you expect from a natural object. Fewer smoking guns than you need for proof. 4 is, we should take this seriously and investigate thoroughly. It does not sound the alarm. Aliens are here. It is. Something is weird and we do not understand it. The problem is that investigating thoroughly requires resources, coordination, institutional support. It requires NASA to release data. It requires observatories to allocate telescope time, and that is not happening. Not because of a conspiracy, but because the scientific community is conservative, because anomalies are usually wrong, because equipment malfunctions are far more common than paradigm shifts. But 1 in 10 quadrillion. At what probability do you change your priors? The critique needs to be substantive. It needs to propose alternative explanations that actually fit the data. Saying it is probably natural because most things are natural is not an explanation. It is a default assumption. And default assumptions are what you hold until evidence pushes you away from them. We have evidence, 9 pieces of it, each one pushing in the same direction. December will bring more data. If the anomalies grow, if we hit 10, 11, 12, at some point, even the most conservative scientist will have to admit that the artificial hypothesis is not fringe anymore, or the anomalies will resolve, and we will learn something important about comets. Science advances either way. But if it goes the other direction, we are in new territory. This brings us to the official response, or the lack of one. On October 21st, the International Asteroid Warning Network, or IAWN, issued an editorial notice through the Minor Planet Center. 3I Atlas had been added to their observation campaign. This is the first time in history that IAWN and has targeted an interstellar object. The network was established in 2014 under the endorsement of the United Nations to detect, monitor, and characterize potentially hazardous asteroids and near-Earth objects. The mandate is planetary defense. The goal is to give early warning. If something is on a collision course with Earth, 3I Atlas poses no collision threat. NASA and ESA have both confirmed it will not come closer than 1.8 astronomical units to Earth, about 270 million kilometers. So why did IAWN unactivate? The official explanation is that comets present unique challenges for astrometry and orbit prediction. The notice states this explicitly. Cometary bodies are extended. They have comas and tails, and these features can pull centroid measurements off the true position of the nucleus. This makes it hard to determine exactly where the comet is, which makes it hard to predict exactly where it will be. For an object moving as fast as 3I Atlas, small errors in position measurement compound rapidly. IAWN wants accurate tracking. This is standard practice for comets that might pose a future threat. But 3 Atlas is not a near-Earth object in the usual sense. It is on a hyperbolic trajectory. It came from interstellar space. It is passing through, and it is leaving. One and done. The threat it poses, if any, is not kinetic. It is not about impact energy. The threat, if we are taking Avi Loeb's seriously, is that we do not know what it is, and we do not know what it is doing here, and we do not know what it might do next. IAWN adding it to their campaign is an acknowledgement, subtle but real, that 3I Atlas is worth monitoring, not because it might hit us, but because it might be something else. The timing of the notice matters. October 21st. That is the date of solar conjunction, the date when 3I Atlas moves directly behind the Sun from Earth's perspective, the peak of the visibility gap. IAWN issued the notice at the moment when Earth-based telescopes could no longer observe the object, when we were blind. Was this routine bureaucratic timing, or was it a signal, a way of saying without saying, that someone in the planetary defense community is taking the anomalies seriously enough to formalize a response? The campaign is described as a training exercise. IAWN uses real targets to practice coordination, to test communication protocols, to refine observation strategies. This makes sense. Planetary defense is not something you want to figure out in the middle of an actual emergency. You drill. 3I Atlas is a good training target. It is fast. It is challenging to observe. It requires international cooperation. All valid reasons to pick it, but it is also a cover if IAWN thinks there is any chance. Any non-zero probability that 3I Atlas is artificial, that it might maneuver, that it might release smaller probes. They cannot say that publicly. They cannot say we are tracking this because it might be an alien spacecraft, without triggering panic, without inviting ridicule. So they say training exercise. They say astronomy is challenging for comets. They say standard procedure, and they quietly allocate resources, coordinate observations, and watch. The campaign runs from late November 2025 through January 2026. That is a 2-month window covering the period when 3I Atlas will be most visible from Earth, when it will be close enough for detailed observations. If the object is going to do something, if it is going to change course, if it is going to release anything, it will happen during this window. IAWN will be watching. There is precedent for this kind of quiet alert. The Oumuamua situation in 2017, during the weeks when Oumuamua was trackable, there was a lot of behind-the-scenes coordination. Observatories were sharing data. Governments were briefed. SETI researchers were consulted. None of this was public. 3I Atlas is getting the same treatment, but more formal. The IAWN campaign makes it official. It creates a framework for data sharing, for coordinated response, for escalation if needed. an escalation to what if 3I Atlas is confirmed to be artificial. What is the protocol? Who makes decisions? Who speaks for humanity? These questions are not answered. They're not even asked publicly, but someone, somewhere, is thinking about them. The involvement of the United Nations is interesting. IAWN operates under UN auspices. It provides international legitimacy if the situation escalates. The UN framework is already in place, now. Most of the astronomers participating in the IAWN campaign probably think this is about comets and astrometry and training. But the people who made the decision to activate the campaign, the administrators and policymakers who signed off on it, they know the context. They know about Avi Loeb's analysis. They know about the anomalies. Planetary defense is not just about rocks hitting the planet. It is about existential threats, and the discovery of extraterrestrial intelligence would be an existential threat, not in the sense of danger, but in the sense of disruption. IAWN targeting 3I Atlas is a data point. It does not prove anything, but it means they are not ruling it out. It means someone is being cautious. And caution in this context is rational. If there is even a 1% chance that 3I Atlas is artificial, the implications are so significant that treating it seriously is the only responsible choice. The campaign will generate a lot of data. If 3I Atlas behaves like a natural comet, the data will show it, and IAWN will conclude the campaign was a successful training exercise. But if the data shows something else, if the orbit deviates in ways that our guessing cannot explain, if the object accelerates or decelerates, or changes direction without apparent cause, IAWN will escalate. The campaign will shift from training to actual response, and the protocols that have been sitting in binders, waiting for a scenario that everyone hoped would never happen, will be activated. We're in a strange moment. The ambiguity is intentional. It allows for preparation without commitment, for caution without panic. But the ambiguity will resolve. Either 3I Atlas is natural and we move on, or it is not, and everything changes. This leads to one of the more unsettling theories. Perihelion is the optimal point for a spacecraft to release probes. You're deep in the gravity well, moving fast, and any velocity change you impart to a smaller object gets amplified by the orbital mechanics. If you want to send something toward the inner planets, toward Earth, or Venus, or Mars, you release it at perihelion with a slight push, and the sun's gravity does the rest. The math is elegant, the strategy is efficient, and 3I Atlas reached perihelion on October 29th, hidden behind the sun, unobservable from Earth, at exactly the moment when such a release would be most effective. Avi Loeb calls this the Trojan horse scenario. The object looks like a comet, appears natural from a distance, raises no alarms, but inside it carries something else: smaller craft, instruments, probes designed for specific missions. The mothership passes through the system on its hyperbolic trajectory. One and done, never to return. But the probes it releases stay. They enter orbits around the sun, around planets, settling into positions where they can observe, collect data, and transmit findings back to wherever the mothership is going. By the time we realize what happened, the mothership is gone, and the probes are embedded in our system, too small to detect easily, too numerous to track individually. This is not science fiction. This is a practical mission architecture for exploring a distant solar system. You do not slow down the entire mothership. That costs too much energy, too much time. You fly through at high speed. You map what you can during the pass, and you leave behind instruments that can continue the observation. If you wanted to study an entire solar system in detail, You would need multiple vantage points, long-term monitoring instruments at different locations. One big object cannot do that. A swarm of small objects can. The retrograde trajectory makes this easier. 3I Atlas is moving opposite to the direction the planets orbit. Retrograde orbits are ideal for reconnaissance because you get multiple encounters with planets as they come around. If you released several probes with slightly different orbital parameters, you could blanket the inner system, ensuring continuous coverage. The question is whether we would see the release if 3I Atlas ejected something at perihelion. Would our instruments catch it? Probably not. The object was behind the sun, visible only to coronagraphs that were barely able to track the main body. A small probe, even a few meters across, would be below the detection threshold. We would not know it was there until it was far enough from the parent body to be resolved as a separate object. And by then, the association might not be obvious. The Galileo project is looking for this. Lowe's research initiative, funded independently, is focused on searching for technological signatures in astronomical data. One of their tasks is monitoring the skies for unusual objects, small, fast-moving things that do not fit standard catalogs. They have 3 observatories now, all sky cameras, software designed to flag anomalies. If 3I Atlas released probes, if those probes maneuver into orbits that bring them near Earth, the Galileo project is positioned to detect them. Maybe there is another version of this scenario. The probes are already deployed. 3I Atlas has been in the solar system for months. Since before discovery, it crossed the orbit of Neptune in mid-2023. It had 2 years inside the outer solar system before we noticed it. Plenty of time to release probes in the outer regions, to seed the Kuiper belt with instruments, to set up a network before coming in close. By the time we detected 3I Atlas in July 2025, the reconnaissance phase might have been complete. If that is the case, we missed the window. The probes are already deployed, already in place, already operating. And unless they want to be found, we will not know they are there. Space is vast. A probe the size of a car could orbit the sun for decades without being detected, unless you knew exactly where to look. The mini-probe idea sounds paranoid, but it is operationally sound if you are a civilization capable of interstellar travel. You do not send one big mission to one star. You send thousands of small missions to thousands of stars. You paralyze. Earth is interesting. We have water. We have life. We have technology. If an interstellar survey detected our signals, they would prioritize us. They would send something to take a closer look. Not a manned mission. Not at first. Too slow, too risky. A probe, fast, cheap, expendable, and the probe would follow a logical mission profile. 3I Atlas fits that profile exactly. The size supports this. 33 billion tons. That is enormous for a comet. But if it is a mothership, if it is carrying payload, if it is designed to survive a 1,000,000-year journey through space, it needs to be big. Radiation shielding, fuel reserves, repair systems, all add mass. Our largest spacecraft are tiny by comparison. The International Space Station is 450 tons. Starship, fully fueled, is about 5,000 tons. 33 billion tons is 7 million times the mass of Starship. That is not a probe. That is a city, a factory, or a generation ship. Or it is just a big comet. The lack of debris is suggestive. When comets shed material, we see expanding clouds, tails, dust trails, evidence of disintegration. 3I Atlas shows none of this. The nucleus is coherent. The structure is intact. It is not falling apart. For an object subjected to solar heating at perihelion, You would expect at least some fragmentation. The fact that it is holding together suggests it is not held together by weak, icy bonds. It suggests structural strength, metal, composite materials, engineering. The stealth aspect bothers me. If 3i Atlas is artificial, it is not trying to hide. It has a coma, a tail, outgassing, all the features of a comet. But why? Why not just be a dark, inert object? One possibility is thermal management. If the interior is warm, if there are active systems generating heat, that heat has to go somewhere. The coma could be a cooling system. Another possibility is that the coma is not camouflage. It is a signal, a way of being visible, of announcing presence. The wow signal might have been the announcement. The coma is the continuation. They are not hiding. They are advertising. December will test this. If 3i Atlas released probes, if those probes are in orbits that bring them near Earth, we might see them. The Galileo project will be watching. Amateur astronomers will be watching. The challenge of detection is not just technical. It is psychological. We see what we expect to see. We filter out noise, anomalies, things that do not fit the pattern. The Trojan horse theory is uncomfortable. It implies we are being observed without consent, studied like specimens. It implies vulnerability. But discomfort is not a reason to dismiss the theory. If it fits the data, we have to take it seriously. The astronomy community is fractured over 3i Atlas, and the fracture lines run deep. On one side, Avi Loeb, the Harvard professor who is willing to say what most of his colleagues will not. On the other side, the mainstream establishment, the peer reviewers, the grant committees, the people who control funding and tenure and publication, and somewhere in the middle, a growing number of scientists who are quietly unsure, who see the anomalies, who recognize that something is strange, but who cannot afford to say so publicly because the professional risks are too high. Lowe's become a lightning rod. He did this to himself deliberately. When Oumuamua passed through in 2017, he suggested it might be artificial, might be a light sail, might be technology. He wrote papers about it. He wrote a book about it. He went on television, radio, podcast, anywhere people would listen. The establishment hated it. They said he was chasing headlines, abandoning rigor, promoting speculation over evidence. They said he was giving ammunition to conspiracy theorists, undermining public trust in science. Some of that criticism is fair. Lowe is provocative. He frames things in binary terms, natural or artificial, comet or spacecraft. He uses media platforms to bypass peer review, to take his arguments directly to the public, which irritates his peers who think scientific debates should happen in journals, not on Joe Rogan. But some of the criticism is not about method, it is about message. The establishment does not want to talk about aliens, not because they are closed-minded, but because the field has a history with this UFOs, ancient astronauts, crop circles. Astronomers have spent decades building credibility, distancing themselves from that noise. When Lowe says 3i Atlas might be a spacecraft, he is reopening a door the establishment worked hard to close, and they resent him for it. Jason Wright, a Penn State astronomer who is no stranger to technosignature research himself, has written extensively about why Lowe's approach is problematic. Wright has his own blog where he meticulously dissects Lowe's claims. He does not dismiss the artificial hypothesis outright, but he argues that Lowe is jumping to conclusions, ignoring natural explanations that fit the data, cherry-picking anomalies and downplaying the uncertainties. Wright accuses Lowe of behaving like someone who wants to be proven right, rather than someone seeking truth. And Wright is not alone. Multiple prominent astronomers have said similar things. The frustration is real. Loeb publishes papers suggesting extraterrestrial technology. And suddenly, every astronomer who studies interstellar objects gets asked by journalists whether they think it is aliens. It forces them to take a public stance.